Hello everyone, my name's Nikesh Patel and today I'm going to be talking to you about how NNL is an organisation of bridge builders. Firstly, I'd like to apologise for my absence today. I'm currently sound asleep as I was working the night shift last night, so I only got to bed at about 7 o'clock this morning. But back to NNL. To be clear, we're a national nuclear lab, so we don't actually build bridges. But what we are doing is bridging the technological development gap between concepts and solutions. And we do this by searching for pioneering opportunities to develop new science and technology right through from its initial concept to being an operationally deployable solution. Now, I studied chemical engineering at university, and as part of my degree I had to carry out a group design project. And our topic was the UK's nuclear waste legacy. And so what we decided as a group was to design a treatment process for Magnox sludge, which is a corrosion product from the storage of spent Magnox fuel. And as many of you will know, it's a very troublesome waste. So we designed this fantastic new innovative process that included, amongst other things, a magnetic separator, which was designed to separate the radionuclides from the bulk of the sludge. And at the time I was thinking, oh, we're in the money here, Sellafield's going to buy this off us, oh, we're all going to be rich. But that didn't quite pan out. And it wasn't until coming to work at NNL that I realised what industry was after were tried and tested solutions for their problems. They didn't want just a theoretical design. And that's exactly what we do at NNL. We work with innovators at universities and other organisations to develop these new technologies right from their concepts through to being the operationally deployable solution that industry wants. And we can do this whether it's a physical process or a flow sheet or a model through the use of our facilities and our expert knowledge. Now, if we take a look at the current situation in our UK nuclear industry, we've got a whole range of wastes that we need to make safe for long-term storage and eventual disposal. So these can be things from high-level waste, so spent nuclear fuel, right down to very low-level waste, so think maybe a contaminated pair of gloves. But what I'm going to focus on today is the intermediate level waste. So this is things like sludges, ion exchange media, and just general decommissioning waste from redundant facilities. And the current baseline treatment method for a lot of this waste is grout encapsulation. And what that involves is mixing the waste with grout in a 500 litre stainless steel drum. So what you do is you encapsulate your waste in a grout matrix. And this has been chosen because it's well known. We've had many years of research into it, and we have operational plants that gives us that real level of operational know-how. And there's been almost this mantra within industry of, if in doubt, grout. If we don't have a better idea, then we're going to go with grout because we know how to do it. But there are downsides to grout encapsulation. It's not a perfect solution. So you actually increase the volume of your waste by roughly a factor of 3 when you encapsulate waste. And also you can have problems down the line with the reactivity of your grouted product. Now, a fantastic example of NNL bridging this technological development gap with a new technology is our collaboration with Veolia on Geomelt. So Geomelt is an example of a thermal treatment process, and to be precise, it's an in-container vitrification process. And how it works is we pre-stage a mixture of waste or a waste surrogate with glass formers in a refractory box. And we then heat it to a very high temperature, somewhere in the region of 1,000 to 1,500 degrees, depending on what the waste is. And what we end up with is a homogeneous glass product, a big square block of glass to be slightly less precise. And the great thing about producing a glass product is that we generally reduce the volume of our waste. So that means we end up with less than what we started with. And also, glass is a very stable, durable product, which means it's very suitable for long-term storage. And through thermal treatment instead of grout encapsulation, there's potential for huge cost savings. So we're talking, even with the costs of building a large-scale processing facility, there could be several £billion knocked off the cost of the UK's overall decommissioning budget. So, how are we doing with the construction of our bridge? Well, we've built very stable foundations. Through working with Veolia, we've commissioned an engineering-scale Geomelt rig into NNL's Central Lab Active Rig Hall, which is based on the Sellafield site. And there's been some key benefits to doing this. Firstly, through having an engineering-scale rig, we have a much better comparison to a large-scale process than we would have if we were just using lab-scale equipment. Secondly, by installing the rig on a nuclear licensed site, we've actually shown straight away that the technology can comply with the conditions of a nuclear site license. And thirdly, by having the rig installed in NNL's Active Rig Hall, we actually have the capability to experiment with real waste as opposed to waste surrogates, which gives industry an exact answer to what a waste form would look like. Now, we're currently examining the feasibility of the Geomelt thermal treatment process to treat a range of wastes. So we're looking at things like sludges, spent 6-ep-clino, plutonium contaminated material, and just general decommissioning wastes. So this is things like rubble and HEPA filters from ventilation systems. And our initial results are showing that with some waste streams, we can reduce the final volume by 60%, which means we have less than half of what we started with. So if we put that into context of final storage and disposal costs, this is huge. So with all these benefits of Geomelt thermal treatment, you're probably asking yourselves why we're not building a full-scale facility right now. And the answer is, we're very comfortable with grout encapsulation as a process. We know how the process works. We know what the waste will end up looking like. We know what might go wrong during processing. And importantly, we know how to sort those problems out when things do go wrong. And these are the kind of questions you need to be able to answer to build a sturdy bridge between your concept and your deployable solution. And through our collaboration with Veolia, that's exactly what we're doing. We're finding the answers to these key questions. We're building our development bridge, glass block by glass block. And we're looking to develop the process to make it a viable alternative to grout encapsulation. So I, for one, am very excited to be part of this waste form revolution. And through our continued efforts, the construction of the Geomelt development bridge will go forward and we'll make it to the other side. Thank you very much for listening.